the previous module, I talked about the solution of rigid rotor, and the rigid rotor which we have taken was having unit dimension r was equal to 1. So we were having only two variables, theta and phi, and the Schrodinger equations which we got, since it was having two variables, so we did separation of variables, and from the separation of variables we got two equations, phi equations and theta equations. So phi equation solution I talked about in the previous module, and now I will talk about the theta equation solutions. The phi equation solution has given you the value of magnetic quantum number m, which has a value equal to 0, plus minus 1, plus minus 2, and the physical significance of the this phi equation solution, eigenfunction of the phi equation, was that it was representing the Lz component, Lz, that is z component of the angular momentum. So this we talked about in the previous module. Now the solution of theta equation is a little difficult than the phi equation, because it again involves the power series method, and we will have Legendre polynomial here. So it is similar to what we did in the simple harmonic oscillator. In simple harmonic oscillator, we talked about a power series, we talked about Hermite polynomial. Here also we will talk about power series, but we will talk about Legendre polynomials. Okay, these polynomials I have taken directly from the mathematics, so you need not to bother from where this equation is coming. I will come to that later on. But after the separation of variables, the theta equation which is obtained is 1 by sine theta, so 1 by sine theta d by d theta sine theta d theta theta by d theta plus beta minus m square sine square theta 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 is equal to 0. See, one thing you must mark, that initially when I have written the equation, I have written del by del theta. Now I am writing d by d theta, because here you have only one variables, so it's not partial differentiation. It's so del you use when you have more than one variables. Okay, here you have only one variable, so I have written d. Now this beta is actually 8 pi square I e divided by h square. This you remember, this we did in the previous module. You can go back and see in the previous video from where we got this equation. Okay, after the separation of variables, the theta equation which we obtained is this one. Okay, if you remember, in simple harmonic oscillator, the first thing which we did, what we did, we changed the variables. Okay, so here also we will change the variables, as previously done in power series method of harmonic oscillator solution. Here also we will change the variables, and we will suppose that x is equal to cos theta. If x is equal to cos theta, then x square you can write as cos square theta, and this will be equal to 1 minus sin square theta. Simple trigonometry, all of you know. Okay, so what you can write, sin square theta is equal to 1 minus x square, and sin theta is equal to root under 1 minus x square. So you have the sin theta here, you have the sin theta here, you have the sin square theta here. So you can change these variables, and furthermore, d theta theta by d theta we can write as d theta theta by dx into dx by d theta. Okay, and d theta theta by dx will be what? D theta theta by dx will be minus sine theta d theta theta by dx. Okay, so if you put these values, into this equation, what do you get? Okay, so sine theta d theta theta by d theta, wait. Okay, so d theta theta by d theta we can write as d theta by d theta and dx by d theta, and x is what? X is cos theta, so it will be minus sine theta into d theta theta by dx. So we are trying to find out this equation d theta theta. Partly this we did, and then again add the sine theta. So add the sine theta d theta theta by will be minus sine square theta d theta theta by dx. Okay, now this equation is equal to minus sine square theta is what? Sine square theta is 1 minus x square. So sine square theta is replaced by 1 minus x square, and then d theta theta by dx remains as such. Okay, since d theta theta by d theta is minus sine theta d theta theta, as previously we did, since this equation d theta theta by d theta is equal to minus sine theta d theta theta by dx, so del by del theta you can write as minus sin theta del by del x. Okay. And if you write this del by del theta is equal to minus sin theta del by del x, see the variables, you have two variables here, so the sign changes del. Then putting these values in equation 1, if you put these values in equation 1, what do you get? 1 by sin theta remains as such, 1 by sin theta. Then you have d by d del by d theta. So d by d theta will be minus sin theta del by del x. Then you have rest of the thing is this one, sin theta d theta theta. So this will be minus 1 minus x square d theta theta by d theta. See, for example, this part, this part is this one. Okay. This you get minus sin theta del by del x. This you get from here, del by del x. Okay. So del by d by d theta is equal to minus sin theta. Okay. And then you have beta into theta theta m square theta theta divided by sin square theta. So that will remain same. Beta is equal to theta theta minus m square sin square theta d theta theta. So just put the values of these equations from 2, 3 and 4 and you get this equation. Okay. Now what you can do is this sin theta and this sin theta will go. Okay. And then you have minus sign here. So minus sign here, inside it will be plus, and you will have only del by del x. Okay. Del by del x 1 minus x square del theta theta by del x plus beta minus m square 1 minus x square. Okay. See, beta minus m square sin square theta is 1 minus x square. So 1 minus x square into theta theta. So this equation 5 we obtain simply by changing considering f to be equal to cos theta, x to be equal to cos theta, and then x square is cos square theta 1 minus sin square theta, and then sin square theta is equal to this one, and from here we get this one. We put these values and you get equation number 5. Okay. So from here we say that equation 5 is known as Legendre equation. In the case of simple harmonic oscillator, I said the equation is called Hermite equation. Now I am saying it's Legendre equation. So don't bother about these details of these equations. Don't go for finding out these unless you are from the mathematics background. You can see and go to the polynomial books. You will find these polynomials, Hermite, Legendre, Laguerre, all polynomials you will get there. But if you are not from the mathematics background, you just consider that we have taken it from the mathematics, Legendre equation. Okay. Now it has physical significance only for values of x between the limit -1 to +1, since x is equal to cos theta. We have taken x. We have assumed that x is equal to cos theta. So the physical significance lies in the fact that it has a value equal to in between -1 and +1. Okay. In order to solve equation number 5, we substitute for convenience from nowhere. Just people have done it earlier, so we are doing it again, and we suppose that theta theta is equal to 1 minus x square m divided by 2 g theta. Arbitrarily, we have taken a function and we say we substitute this function, arbitrarily taken function, into the equation number 5. So equation number 5 was this one. Okay. So So this becomes equal to d theta theta by dx. If you take this function, then you can take the differential of this function, and this will be m divided by 2, 1 minus x square, m divided by 2 minus 1, obviously. Okay. And then minus 2x g theta. G theta we have kept constant, and then here we keep the first term 1 minus x square m divided by 2 constant, and we divide it by we differentiate the g theta function. This is the first differential function. Prime indicates this should have been prime. Prime indicates the first differential. Okay. So this I have written it. This is the first differential. So here we are in the second part we are differentiating g theta. In the first part we are differentiating the first term. First two terms you have, first term and second term. So that's the normal process all of you are aware of doing the differentiation. So d theta theta by dx we can find out. Now you multiply this equation by 1 minus x square. This equation you multiply by 1 minus x square, what do you get? 1 minus x square, left hand side will be d theta theta by dx. On the right hand side you have m divided by 2, 1 minus x square, m by raised to the power m by 2 minus 1. So if you multiply this function by 1 minus x square, it will be minus 1 plus 1. So here you will have m by 2 only. Okay, and rest of the thing minus 2x g theta 1 minus x square m divided by 2, and now you are multiplying the second half with again 1 minus x square, so it will be plus 1, and g prime theta will remain as such. Okay, so if you now write this equation d dx of 1 minus x square d theta theta by dx. So what you are doing? You are finding out the differential of this equation, d by d theta of this, d by dx of this, and d by dx of this, right hand side and left hand side. So d dx of 1 minus x square d theta theta by dx okay. So d dx of this function minus 2x d theta 1 minus x square m by 2 plus 1 into g prime theta. So take the differential of this one and you get this function. d dx of 1 minus x square d theta by dx becomes equal to minus 2 m by 2 1 minus x square and all those things. And ultimately, see if you are differentiating again, so this will be g double prime theta. So this will be g double prime theta, because double differentiation you will have to do. And again you see here you have 1 minus x square m by 2 and x g theta, so it will be like this one. So differentiate this one, differentiate this one, you will have first term, then second term, then third term, then fourth term, and then fifth term. All these terms you will get. Okay, and finally if you cut those things, 2 and 2 and this 2 and 2, this 2 and 2 will go by this one. So finally what you get, inserting these values from equation number 6 and equation number 7 in equation 5, what you get is del by del x 1 minus x square d theta theta by dx plus beta minus m square 1 minus x square theta theta. This was your equation number 5. So if you put the values into this equation, what you get is this equation number, I think 5 prime you get. Okay, just to name it. Now you divide this complete equation by 1 minus x square m by 2. If you want to, unless you do one thing more, when you start doing listening these lectures, you must have your pen and notebook there, and you should not just listen to the lectures, you should copy it and you should try to do it on your own, because the solution is there, every step is there, but unless you write it on your notebook, you will not be able to understand that how do you get this. Okay, so if I just tell you that if you are differentiating this part, okay, if you are differentiating this part, so this 2 minus 2 I have taken here minus 2, okay, then 1 minus x square m by 2 and g theta. Okay, so what did I differentiate? I differentiate x only. In the first equation I differentiated x only, nothing else. Okay, and thereafter what did you do? If you look at this one, I differentiated m by 2 and m by 2, it means I am differentiating this part. Okay, so that is the m by 2 minus 1. Then you see what did I do? Minus 2x g theta. Okay, so I differentiated this one, I differentiated x, and then this part will, the rest of the part remains same, and then here what did I do? I differentiated g theta. So one part, second part, and third part. So the up to 3 part I have differentiated this level. Okay, differentiation of, let me write it. I hope you will not have any issue. This was ddx of x. This is ddx of g theta, and this is ddx of 1 minus x square into m by 2. Okay. So we have these differentiations, and finally you get these equations. Inserting these values from equation 6 and 7 in equation 5, we get this equation: del by del x 1 minus x square, del theta theta by del x, plus beta minus m square 1 minus x square theta theta is equal to 0. Okay. Once we have once you get this equation number 5 after inserting the equations, then you divide the complete equation by 1 minus x square m divided by 2. And obviously, if you divide it, what do you get? From the first term, if you divide, this term is same, so you get minus m g theta only. From the second term, what do you get? M square x square 1 minus x square divided by, see, this is m by 2 minus 1, and you divide by 1 minus x square m by 2. So what will happen? It will go, plus 1 and minus 1 will go, and you will have minus 1, so it will be 1 minus x square. So the equation is a little bit simpler because we have divided it by 1 minus x square divided by m by 2. Okay. Then you bring g theta as common, and if you take g theta as common, then what do you get? You get minus m here, then m square x square 1 minus x square, plus beta terms, all g theta terms we have g theta and g theta. Okay. Then you have g theta prime and g theta prime, two terms, and you have g double prime theta. So g theta terms are minus m first term, then your second term is m square x square 1 minus x square, and then third term is g theta, third term is this one, m square 1 minus x square. Okay. And then plus beta. So with g theta you have 1 term, 2 term, 3 term, and 4 terms. So all these 4 terms, coefficients are here, g theta, m square x square 1 minus x square minus m plus beta minus m square 1 minus x square. For g prime theta, you have these 2 terms. So g prime theta minus mx is coming from here. Okay. And then m by 2 plus 1 from here. Okay. And then this what we did, then minus 2x from here for g prime theta. Okay. And g double prime theta is only 1 term, that is 1 minus x square, so 1 minus square g double prime theta. Now it's a little smaller equations. Equation appears to be very big, but the concepts are very simple. So you start doing it on your pen and paper, and you will understand that these are very simple equations, except this, that it looks very big equation, but it is not big, not very difficult to understand. Okay. So once you have this one, then you see with the g theta you can write, rearrange, and beta minus m, and then these two are the same, so it is same denominator, so you can write m square x square minus m square divided by 1 minus x square. Here what you can do, you have g prime theta, and then you multiply this with this one, and you get minus mx minus 2x. Okay. Because if you apply with minus 2x, then you will have minus term here, and 2 and 2 will go, you will have mx and minus 2x also. So simple multiplication will give you, from this equation you can get this one, and 1 minus x square g double prime theta is there. Okay. So again, further simplifying this equation will give you g theta beta minus m minus m square x square 1 minus x square, m square we have taken common, and now it is 1 minus x square I have written, so a minus sign here, 1 minus x square. Then g prime theta minus 2mx minus 2x, and then plus 1 minus x square g double prime theta. So it's not a difficult task, simple rearrangement. And thereafter, once you have this one, then what you can do, say g theta beta minus m square. Minus m x, because this 1 minus x square and 1 minus x square will go. So you have beta minus m square only. Beta minus m square, and g prime theta minus 2mx minus 2x. So it should be minus 2mx minus 2x, it's same, and then 1 minus x square g double prime theta. Okay. A little rearrangement again, beta minus m into m plus 1 we can write. M minus m square I have written in the another form, m into m plus 1. And then again g prime theta 2x m plus 1, and then 1 minus x square g double prime theta, same as such. So g theta beta from this equation we can write beta minus m into m plus 1 plus minus 2x I have brought outside, minus 2x m plus 1 into g prime theta, and 1 minus x square this one. Now we suppose beta is equal to beta minus m into m plus 1 is equal to lambda. Beta minus m into m plus 1, we suppose this to be equal to lambda. Okay, and m plus 1 is equal to alpha. M plus 1 is equal to alpha. So what we can write? We can write 1 minus x square g double prime theta. The last term is the first term in this equation number 8. Then you have 2 alpha x minus 2 alpha x g prime theta, and then you have lambda into g theta. So double differential is the first term, then single differential, and then without differential of g theta. Okay. So we get equation number 8, and this equation number 8 is very similar to the equation which we obtained in simple harmonic oscillator for the function f. So this g theta can be expressed in a power series as we did in the simple harmonic oscillator. So if you go for a power series, then again what you write? Exactly in the same way we did earlier. G theta is a naught plus a0 plus a1x plus a2x square plus a3x cube plus a4x4 plus a5x5 and so on, an xn, and for nth term. We have g prime g prime means the first differential, g double prime means second differential. So we will find out the first differential and second differential of this g theta also, exactly in the same way which you did earlier. So you do not have an x here, it will be a1, 2a 2x, 3a 3x square, 4a 4x cube, 5a 5x4 and so on. So this is your first differential. A second differential also we will find, and then we will put these values of g theta, g prime theta and g double prime theta into equation number 8. Okay. So g double prime theta will be 2a2, 6a 3x, 12a 4x square and so on. Okay. So finally you get this one. And again you put inserting these values in equation number 8. I said equation number 8 was very simple. So g double prime theta, first you will put, so g double 1 minus x square, and g double prime theta is this one. This is your g double prime theta. Okay. And then you have 2 alpha x into g prime theta. 2 alpha x into g prime theta. So this part is actually g prime theta, and this part is g theta. Okay. So we inserted these equations, we represented g theta in a power series, and then we inserted this power series and the first differential and the second differential into equation number 8. We got this one. Now we say that in order that the series may be 0 for all possible values of x, the coefficients of individual power of x must vanish separately. Okay. So again we go by the same logic as we did in the simple harmonic oscillator, and we separate the coefficients of each power of x. So if x is equal to 0, how many terms you have? There actually I did that, I color coded those coefficients. Here I have not color coded, you will have to find it out. Okay. So the first term will be 2a2, because if you multiply 2a2 by 1, it will not have any x. Okay, and then you will have another lambda a naught. So lambda a naught is the first, with so x raised to the power gives you only these two terms. Similarly, coefficients of x raised to the power 1 will be this one 6, because you will multiply it by this one 6a3x. Then you have 2 alpha 2x. Then you have lambda a1x. So these three are the coefficients of, I will encircle for your convenience. These are for x raised to the power 1. Okay. So same way you can, and I have rearranged it, nothing, a1 is equal to lambda minus 2 alpha. Okay. So same way you will find it for higher values also. So you will separate the coefficients and you will equate it to 0. For x square, equated to, for x cube, this will be, for xn you will have this equation. Now if you want to put n is equal to 3, then you put n is equal to 3, this will be 3 plus 2 will be 5, 3 plus 1 will be 4, and 5 multiplied by 4 will be 20. So you have 20 here. A n plus 2, n is 3, so a5 you have, minus n minus n into n minus 1, n is 3, so 3 minus 1 is 2, and n is 3, so 2 multiplied by 3 is 6, so 6 alpha 6 a 3 you get, so 6a3 you get. Then minus 2 alpha n into an, so minus 2 alpha into 3a3, 2 alpha into 3a3 you get, plus lambda into an, so lambda a3 you get. So just put the n values, so n could be 0, 1, 2, 3, 4, anything n could be. Okay, if you put n is equal to 2, you get this series. If you put n is equal to 1, you get the previous one. So a general equation for the coefficients of x raised to the power n we have written here. The same thing we did in the simple harmonic oscillator also. Okay. Once you write this one, then you can rearrange this equation, and n plus 2, n plus 1, a n plus 2 minus n into n minus 1 a n, and you rearrange this one to get this equation, from which you can get different terms. If you put n is equal to 0, okay, then you can get n a2 value. If you put n is equal to 1, you get a 3 value. If you put n is equal to 2, you get a 4 value, and so on other values you can generate. Okay. Substituting these values of alpha and lambda in the above equation, alpha and lambda we have taken as what? If I go back, alpha and lambda. Alpha was m plus 1 and lambda was beta minus m into m plus 1. So if you substitute these values, then alpha was m plus 1 and lambda was beta minus m into m plus 1. So if you substitute these values, this equation changes to this equation. Okay. So alpha was m plus 1 and lambda was beta minus. So we have substituted these two values from this equation, you can get this one. Okay. Now again further rearrangement, 2nm plus 2n. So it's simple algebra, 2nm plus 2n plus n square, you get this one. And finally what you get is equation number 9. This is called recursion formula for the coefficients of the power series g theta. Recursion formula for the power series of g theta. The same recursion formula, similar recursion formula we obtained in case of simple harmonic oscillator. If you remember, it was a k plus 2 and a k value. Okay. So that I said you that there could be an odd series and even series, and we can break this by taking the numerator equal to 0, and the similar thing we will be doing here also. Okay. So I think I will give you a break for this, because we have done many equations here, which appears to be big equation, but it is very simple if provided you take a pen and paper and you try to do it yourself. Okay, because every step is there on your with you, and now you have to just do it on yourself, and you will find the solution to be very easy. Okay, so how to use this recursion formula and what informations we get, and how do we get the eigenfunctions for theta from theta equations. This will be the next module. Okay, thank you.